Hello everyone. This video will be about random number generation. Now, random number generation is something that happens in a program when it randomly gives you numbers within whatever range you kind of tell it to. It's used in a huge number of applications, games especially, because you have to have some random numbers happen. Let's take dice, for example. Most but particularly old computer games, even new computer games, are based on dice. The old tabletop RPGs where you rolled dice to see if you hit something. You rolled another dice to see how much damage you did. That is still very much used today. The only difference is you're using a computer instead of an actual physical dice. Also used in these virtual casino games and various other things. If I swing my sword at a creature, how much damage will I do? It usually won't be the same every single time. All that is random number generation. Now, some games will actually use random number generation like to just randomize the entire world where everything's laid out. It can get, even music can be randomized to a certain extent. If you Google, random MIDI generator, for example, that uses random number generation to make beats and songs. Maybe not particularly good ones, but if you have some sort of random playlist, it like to play various songs that you have. You hit a button, it randomly shuffles and picks a song. It's basically running a random number generator and grabbing a number and playing that location. So it's used everywhere for anything you can think of. Casinos especially, although their random number generation is a little bit more weighted in a sense. A slot machine, if it was completely random for slot machines and stuff at casinos, they'd just lose their shirts. But they have to pay back a certain percentage. It depends on the state and where you're at. It could be anywhere from 80 to 90 something percent. But by that token, let's say if it was 95% or something that they pay back. That means for every dollar you spend, they're going to keep 5 cents on average. Now, it's not going to work out like that all the time. You may lose all your money and the person next to you gets $5, or vice versa. But they actually have machines and things like that to keep track of how much money has been paid out, how much money has been pulled in. Uh, and when we're dealing with those slot machines and stuff like that, when you press a button and all the little things spin and light up, it already knows what the outcome is. It's just doing that for performance. And this is true in all games. You need random number generators for everything you can think of. Even things that aren't games sometimes require random number generation. So let's see how C++ deals with random number generation. So I'm going to, of course, make a new project, and hopefully nothing will break. Console app. And I, again, usually like to put the same date, whatever today's date happens to be. I'll just put the first. All right, so, and then this is just random numbers. And then I just create. And save my Toy Story thing. Okay, there we go. Now, of course, as always, I kind of have a little template set up. So, using namespace, st there. And then I can get rid of that little extra thing. You don't have to do that, but I find it helps. All right, less writing throughout the entire program. So in order to do a random number generator, there's actually a built-in function inside of C++ called rand. And what we're going to do is we're going to print rand and see what it looks like, and then we're going to take it kind of a step at a time so you can see how it works. So I'm just going to cout rand. And I'm going to run it and see what I get. And 41. Okay. Boop. And if I were to run it again, oh, well, 41 again. Okay. Let's hit it a few times and see what happens. Well, it's still 41. Let's see here. You think we get something? Oh, wait, you can't even see that. There we go. All right, well, let's see what happens if I print out a second one. We'll see if we get the same number. Oh, wait, there we go. I forgot to put a little space in between, but that's okay. We'll do that in a second. Let's just go ahead and inline. There we go. Inline. All right, so let's take a look at these numbers and what it's doing. So we run 41, 18,467. Okay. If I run it one more time, still getting the same kind of rotation. And I think I know what's happening. So I'll try to explain a little bit of it. Rand, overall, is a random number generator. Now, if any of you have ever played Minecraft or anything like that, at the very beginning of Minecraft, like if you create a new level, it gives you the option to use a seed value. Now, a seed value basically allows it to, the whole world's randomized, quotation marks, but really it's randomized because of that seed value. If you put in the same seed value every single time, then guess what? It's not as random anymore. So now we've got this. Let me pause for just 1 second and fix something. All right, where were we? I believe we were talking about seed values. Now, let me adjust my extra little things here. There we go. So when we run this, you'll note one major thing, and that is that the numbers are the same every single time. And that's because it uses a seed value to kind of, basically this rand here is just a fancy little mathematical formula that when you plug in a number, it gives you, some other number. And in order for us to make use of that, we have to do a little bit of adjusting. So whenever I want to use random, I'm going to have to add in a little extra here. So in this case, we're going to include time.h because we're going to use a time function. Now, the way the most random generators work is they usually use the system clock, like Java and Python, for example, would use whatever the current time is. Obviously, C++ doesn't do that exactly. That's why you get the same set of numbers every time. And that's not necessarily a bad thing. If you want to test something reliably and you know what those numbers that are going to come out will be, then you know what your output should be. But in this case, we want it to actually be random. So I'm going to go here, time null. So basically, I'm just wiping out the seed value, and it'll reset to whatever the system clock is, or at least that's what this should do. So this is for resetting that seed value for the random numbers. So if I run this now with my little reset here, and this is something you're going to have to put in every time you want to use a random number, let's see if we get a different number. Well, look at that. Different. So first stage, and we got some 7,000, 5,000. We'll run it again. 26,000. So we are getting different numbers this time. Our first number is still kind of similar, though. 7320, 7340, 24. All right, it's changing a bit. All right, so this nulls it out and then basically resets it to kind of whatever the current time is. That's what I'm guessing. We can Google this later and get a little more in depth, but this will allow us to get some slightly different numbers. Now, there is one thing that we're having an issue with at the moment, and that is it just seems to be outputting some massively different numbers than what we probably would want. So let's say I want 0 to 9, which is a fairly standard one here. So I'm going to come here, and I'm going to go int, we'll just call it number 1 equals rand. And if I want between 0 and 9, I'm going to use this percentage 10. Now, what this is going to do, what percentage does, is it's modular arithmetic. So I think I've mentioned this in class before, but percentage is modulus. Effectively, if rand ends up being 42 or 48 or something, it's going to basically take away 10 until there's nothing left. and then I'll have 8 left over. So it's going to give me the remainder. So if I run this, we end up with, let's see, oh, well, I guess I have to kind of print it for us to see it. So let's do that. Okay, so we'll do a little quick print. And there's 5. Okay, we'll run it one more time. 9. We're back at 5 again. Okay. We're at 1. And we're at 1 again. 4. Okay. So as you can see, it kind of gives me a different number each time. Now, the percentage 10 here will give me 0 to 9. It won't give me 1. It'll only give me 0 to 9. Now, if I happen to want something that's, let's say, 1 to 10, for example, then I'm going to need to do one more thing. And that is this. Add a +1. And I'll make this number 2. Okay, I don't crash. There we go. So the +1, notice it's outside the parentheses here. So what's going to happen is we're going to run this function. It's going to get us our big or small honking random number. And it's going to subtract 10 until it can't do that anymore. So that means that'll get me 0 to 9. Now, after I get my 0 or 9, it's going to add 1 to it. So this will give me 1 to 10. So if I have a 0, which is the lowest this can go, I'll end up with 1 because this +1 makes it a 1. If I make a 9, then the +1 will make it a 10. That's why it bumps up the range. Now, if I were to do +5, then the range would be 5 to 5 plus 9 is 14. And this is kind of how you can tweak the range for what you need. It's really not difficult math. It does take some people a little bit of practice to get used to it, but if I want to swing an axe and it's going to do 100 to 150 damage or something, then, if 100 is the minimum, like that, then I just need to have 50 here, which would be 51. That would give me 0 to 50. 100 gets added to the smallest one, which is 0. 100 gets added to the biggest one, which is 50. And I end up with 150. So it just takes a little bit of practice to kind of get those numbers down. But let's take a little look and see how that looks. 5 and 7. Okay. And if I run this a bunch of times, 5 and 1, 8 and 7. There we go. 8 and 4. And there are a couple of other things I can do to this other than null too. Just depends on how what specifically you want to do. This resets it fairly quickly. There are another couple of tweaks we'll go through in some of the later programs where we can adjust a little bit more, but we'll go through that next time. And that is your quick rundown on random number generation.